So number one had you simplifying tangent of x times sine of x plus secant of x times cosine squared of x. Now I want to put a disclaimer on not just this problem, but all the problems in this quiz, that what I'm showing is not the only way to do things. I'm not even claiming it's the best way to do things. It's just simply the pathway that I particularly took. So if your mind works differently, if you want to take a different path, that is 100% a-okay. But if you are completely stuck and lost and not sure what to do, well, here's an insight to some ideas. Now, the first thing I recognize is that secant and cosine are reciprocals of each other. And I know that when you multiply two reciprocals to each other equals 1. But here I have an extra cosine because of the squared here. This is what I mean. I recognize, well, let's turn everything to sines and cosines. I think you'll see it then. So tangent is sine of x over cosine of x times sine of x plus, and secant, since it's the reciprocal of cosine, is 1 over cosine. And we have times cosine squared. Hopefully it's very easy for everyone to see that we now have sine squared x over cosine plus cosine squared x over cosine. So they now have the same denominator. So we can put them together as one fraction. And then we should know Pythagoras' theorem, or Pythagorean identity, that says sine squared x plus cosine squared x is 1. And of course, 1 over cosine is secant. So number one should have simplified to a plain old secant of x. Number two and beyond are proof problems, or verifying problems. So number two asks you to verify that sine of theta over 1 minus cosine of theta is minus cotangent is equivalent to cosecant of theta. Now, in a proof problem, your final line, your final result is not the answer, but the entire work. So I want to make sure that from start to finish, the work is pristine. I'm going to declare that I'm going to start on the left-hand side. And I think the first thing I'm going to do is convert everything into sines and cosines. So we have sine of theta over 1 minus cosine of theta minus, and I should know that cotangent is cosine of theta over sine of theta. Here we are multiplying two fractions, and to add and subtract fractions, the denominators need to be the same. So the LCD would be sine and the 1 minus cosine together. So the left fraction needs to be multiplied by sine over sine, and the right fraction needs to be multiplied by 1 minus cosine over 1 minus cosine. So that gives us sine squared minus cosine of theta times 1 minus cosine theta all over 1 minus cosine theta times sine theta. In case you need to see it, what we did was we multiplied the left fraction by sine over sine, and we multiplied the right fraction by 1 minus cosine over 1 minus cosine. So that is what we did. Now, when I do LCDs, I typically do not multiply up the denominators, but I do go ahead and do the math in the numerator. So we have sine squared theta minus, and if I distribute, negative cosine times 1 is a minus cosine squared, or cosine, and then a minus cosine times a minus cosine is a positive cosine squared. We should recognize that sine squared, a positive sine squared with a positive cosine squared, is a 1. So that guy there that I've highlighted, those guys combine to a 1. And you can see why I almost always do not multiply out the LCD, because in this case they cancel out. So these guys here are gone, they cancel out. So we're left with 1 over sine of theta, which is cosecant of theta, which is the right-hand side as we want. So that is the chain of logic that takes the left-hand side, sine over 1 minus cosine minus cotangent, to the right-hand side, cosecant. Number 3 asked you to verify that cotangent squared theta minus cosine squared theta is the same or equivalent to cotangent squared theta times cosine squared theta. So let's go ahead and do this. I think I'm going to start on the left-hand side. And just as we did before, I'm probably going to convert everything to sines and cosines. I'm not sure if it's going to work, but hey, why not? We'll see. So we'll have cosine squared theta over sine squared theta minus cosine squared theta. I recognize I'm subtracting fractions, so I need the common denominator. So this guy here needs a sine squared over sine squared. That gives us a cosine squared theta minus cosine squared theta sine squared theta all over sine squared theta. In the numerator, we should recognize that they both have a factor of cosine squared theta, so we can go ahead and factor that guy out. That leaves behind a 1 minus sine squared theta. And anytime you have a trig function being squared, especially when it's connected some way to the number 1, you should be thinking of the Pythagorean identity. And we should know that 1 minus sine squared theta is cosine squared theta. So we have cosine squared theta over sine squared theta. And I think that does it, right? Because we are looking for cotangent. And what do you know? There's our cotangent right there. So in the end, we have cotangent squared theta, cosine squared theta, which, correct me if I'm wrong. Yep, that's exactly what we wanted. That is the right-hand side. Okay. And last but not least, number 4 asked us to verify secant theta times cosecant theta times tangent theta plus cotangent theta is equal to secant squared theta plus cosecant squared theta. Once again, I'm going to start on the left-hand side just because I feel like it. It looks more complicated. And as before, let's just convert everything to sines and cosines. So secant cosecant is the reciprocal sine and cosine. So that's 1 over sine times cosine. Order doesn't really matter. I guess I should go in order. The reciprocal of secant is cosine. Reciprocal of cosecant is sine. Times tangent is sine over cosine. Plus cotangent is cosine over sine. Now, most people traditionally would try to combine this as one fraction, but I notice that we are multiplying here. And I see a lot of sines and cosines and things should cancel. So that's actually what I'm going to do first. I'm going to distribute this guy in here. I hope everyone can agree that when you do the first distribution, these signs should cancel out because we have a sine on top, sine on the bottom. And we're left with 1 over cosine times 1 over cosine, which is 1 over cosine squared. When I do the next distribution, I hope everyone can see that the cosines will cancel out because you have a cosine on top and bottom, and you're left with sine times sine in the denominator, which of course is 1 over sine squared. And guess what? I believe that is it. That's all we need because we know that 1 over cosine squared is secant squared plus, and we should know that 1 over sine squared is cosecant squared. So the last one actually ended up being the simplest. So that is the solution to our 7.1 quiz.